Here goes our final topic for this course. This is the first of maybe 3 versions of the same question we're going to do. And then there's a bit of home reading you have to do, and the course is finished. So let's start with the first of these 3 examples that I will cover with you. The question is here at the top left. It might look confusing or daunting at first, but it won't for long. A computer has a main memory which stores 1 cell per word and 2 words per line. The 2 words per line, here, I just noticed something, there's a mistake here. The 2 words per line is a tiny bit of spatial locality. It also has a cache capable of holding 4 lines. Let's make it a direct mapped cache. An executing program reads data in 3 passes from a set of address sequences as shown below in decimal format. Decimal just means base 10. Pass 1. Those 20 cell addresses are being referenced. So you can see there's a bit of temporal locality, 4, 4, and a lot of spatial locality. The program tends to be thrashing between 0 and 9 and 449 and 454, something like that. There's 2 areas of memory that are thrashing back and forth, fighting to be in the cache at the same time. Show the contents in tabular form, so a table, at the end of each pass. Calculate the hit rate for this example. Assume that the cache is initially empty. Okay. Let's try it. I'm going to draw 4 lines of cache and 3 passes. It's a direct map cache. There's no sets like we did last time. Not yet. Here's what the cache looks like now. Initially empty. And then I can say pass 1, pass 2, pass 3. And we'll see what the cache looks like at the end of each pass. It's very easy to make little mistakes here that cascade into huge mistakes. So let's be very careful on these kind of questions before we have some kind of test on them later. Let's start obviously with pass 1. The cache is empty. There's the 4 lines. Let's put them here. Line 0, line 1, line 2, line 3. Nothing new yet. 0. Well, there's 2 words per line. So if we look at things here, if we look at cell number and, oh, something happened. Cell number and block number. Oh, it doesn't allow tabs, I see. That's too bad. Alright. Cell number, block number. Well, cell 0 and 1 are in block 0. How do I know that? It says there's 2 words per line, therefore there's 2 words per block. And then 2, 3, 4, 5, 6, 7. So you can see with more spatial locality, it would be, 128 words per line or something. But right now it goes even is the first word, odd is the second word, or the first and second cell in each block, in each line. So if I told you that, well, here, let's go down here. And the next section that we really care about, so I'll say ... 448, 449, and so on. Let's try to cover all these. This will come in handy for our next questions as well. And then there's more. Let's just assume there's millions of cells. We don't know. And then if I look at the block number, There's the first 5 blocks. Then if I go down to 448, well, if I divide it by 2, I can find out what block it's in. 448 divided by 2. There are the blocks that I think we're going to care about in this question. And it's the blocks that get mapped to lines of cache. Remember that. It's not actually cells. So block number, and let's keep going. Line number. Block 0 goes in line 0. Block 1, block 2, block 3. Now, block number 4 can't go in line number 4. There is no line number 4, so it goes in. If I take the block number and mod it by the number of lines, it goes back in 0. It wraps around. So it goes 1, 0, 1, 2, 3. Block 4, 5, 6, 7. Block 8, 9, 10, 11. So next question is, if I ask where does cell 449 go, first question is what block is that in? That goes in 224 with 448. They always start with the even and the odd. So anytime you pull in 449 to the cache, 448 comes, and vice versa. 449 never goes with 450. So now 224 mod 4 is also 0. Just by fluke. It comes out nice and neat like that. So you can see there's going to be some contention. They will be fighting. Some of these blocks want to go in the same line as the other ones. There's lots of fighting for line 0. They can't go in there at the same time, so there will be eviction or overwriting. Okay, so let me get my pen, see if this is going to work. I hope it does. 0 goes with 1. So up here, when 0 goes in the cache, it also brings in 1, because there are 2 words per line. And then when 1 is requested next, that's a hit. So I can keep track of my hits over here. One hit. 2 is not a hit. It's not in the cache. So 2 needs to go in there. Well, 2 goes with 3 in line 1. So you can have 0 and 1 at the same time as 2 and 3. So when 3 is requested next, well, our spatial locality gets that, and that's called a hit. It's in the cache. So I can give it a check mark if I want. 1 was a hit. 3 was a hit. Next, 4 was a hit. 4 is not a hit. 4 is a miss. 4 is in block 2, goes in line 2 with 5. Then 4 is requested again. That's a little bit of temporal locality. That's a hit. And then 5 is requested. Well, that's a hit. That was already in there. But 6 is not in there. So we have to pull in 6 along with 7. 6 is not a hit. 4, another hit. 7 now, that's a hit. It was pulled in with 6. 8, oh no. Here's some fighting. This is overwritten. And 8 and 9 are put into line 0. So when 9 is here, it's a hit. It was pulled in with 8. 8 is a hit the second time. It's still in the cache. 7, that's a hit. So we can see a bunch of spatial locality going on here. 6 and 5. Those are already in there. 2 more hits. 450. A big change. 450 goes in line 1. So 2 and 3 are gone, or overwritten. And instead, 450 along with 451 is put into that line. It's not a hit. 452. So the computer has moved on to a different section of the program, I guess, or a different program. 452 goes in line 2 along with 453. 454. Well, 454 goes in line 3. I've already mapped it out over here. You go from cell to block, block to line. 454 and 455. And then 454, some temporal locality. That's another hit. So far, the hit rate is 12 out of 20. There's 20 fetch requests by the CPU. So each one of these started as a program counter value. 8 misses, 12 hits. So far, after pass 1, the hit rate is 12 out of 20. Let's keep going. It says the cache is initially empty, but it's not empty now. At the start of the second pass, 8 and 9 are here. Whoops, I should have crossed those ones off. 450 and 451 were in here. Sorry, it's so messy. I'm doing my best. 452 and 453 were in here. And 454 and 455 were in here. If we had a bigger cache, we could have fit everybody in here. There wouldn't be this overwriting. But we don't have a bigger cache. Pass 2 starts with 450. 450 is a hit. So let's make some more hits. Pass 2 hits. I'll just put a number 1 and we'll count them later. 450. Another hit. 451. Another hit. 449. No, but you can tell where it's going to go. It goes before 450. Along with 448, 449. This is gone. So 449 was a miss. And then we have this called thrashing, going back and forth. 0 once. Line 0. Along with 1. 0, 0. Hit, hit. I can do it with check marks too to have a picture to double check my work later. 1, 2, 3. Well, 1 is a hit. 2, 3 is going to kick this out of here. This is a direct map cache. There's no thinking. There's no looking for the least recently used. Nothing. Just block 1 goes to line 1. It overwrites it. No looking, no searching, no flexibility, no choice. So 2 was a miss, but 3 is a hit. 0, that's a hit. 2201. 2201. Hit, 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 hit. Now we get this thrashing back and forth again. 449. Well, 01 is gone, and we're back to 448. 449. 449 the second time is a hit, so is 448. 451. Terrible. We are evicting the most recently used. It's not good. And 2. So again, oh, that one's okay. Thrashing. So in pass 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of 20. So if we do pass 1 hits, we had 12 out of 20. So far we're at 26 out of 40. Not too bad. And that's because I did use spatial and temporal locality in my examples. Now, pass 3 is exactly the same as pass 2. So you might expect it to have the same exact hit rate, 14 out of 20, but that's not true because it started with different content in it. It didn't have 8, 9 to start with this time. It had 448, 449. This one had 2, 3. And the other ones haven't changed. Okay. Let's run through this final pass and calculate the hit rate out of 60.